Okay, hello everyone. This is again your host Sharir Al Mustakimito. Okay, so today you're hosting another event, and this is our expert talk session again in another Friday. So I'm delighted to invite Darshna with us for this expert talk session. So without any further ado, I will just add her to the stream. Hello, Darshna. Can you hear me?
Hi, Sharia. Yes, I can hear
Yeah,
you. Great to be
yeah.
here.
How are you?
I'm very good, thank you. It's a
Thank.
surprisingly sunny day in London for September at
Ah,
least. We've had quite a lot of autumnal weather prematurely, so yeah, definitely enjoying the last of the sun.
yeah, that's great. Thank you so much for accepting the invitation and manage some time for our community folks. So, would you please introduce yourself to our community?
Yeah, absolutely. So I'm Darshna. I'm the Chief AI Officer at a tech consultancy um, called Acora, and I'm also a Microsoft AI MVP. So I do a lot of community-based activity. I run the Data Science London group based in London. We have over 10,000 members and try to meet monthly to discuss the latest kind of innovations in AI specifically. A little bit of background around me so I've been in machine learning and AI for the last decade. Prior to that, my background was actually in neuroscience. So I kind of transitioned into technology from still a STEM subject, but not a traditional computer science background. But it's been a great journey. I've seen us go from using traditional machine learning, developing traditional machine learning models to actually just consuming them and worrying more around data quality and the evaluation now that we have the power of generative AI at our fingertips. So seeing that implemented across my decades of experience has been quite interesting, and seeing that change from how small businesses use machine learning and AI through to large enterprises and the additional levels of governance and monitoring that are needed and assurances has been definitely quite interesting.
So that's a long journey and lots of learning, right? Okay, great. So let's start the session then.
Okay, perfect. So thanks for joining everyone today. I'm going to be talking to you about how you can really easily get started with building a carbon impact agent. And I'll tell you a little bit more around why I want to present this to you. But I'll give you an overview of what we're going to cover today and then get straight into it. So we'll cover what an agent is, when to use agents in AI design, why would you build a carbon agent to start with, um, a little bit around what are the foundations that we need to get right in terms of data quality, standard operating procedures, and prompt engineering. There are a whole host of development tools out there now, some that are low code and some that require coding skill. And when you use one or the other is quite an important distinction to make, because they both have their advantages and disadvantages. But it's important to understand when to use a low code solution versus code first. So I'll put that out there for you to consume. I'll take you through how I've gone about building this simple carbon agent, and then I'll show you how it works under the hood, as well as a very simple UI that I've built via Chainlit. And then we'll wrap up with some conclusions, some next steps that I'd probably iteratively improve this agent with, and I'll leave you with some resources to go check out as well. So as I mentioned, I would like to give you an overview of how to build an agent in a really simple way. So rather than thinking of a really complex agent, we want to build it from the ground up and then iterate on that development. And I want to apply it to a real world use case, because there's a lot of tech blogs and tech content out there that show you how to use the tech. So I think that's very well resourced. But what isn't so well resourced is the application of these technologies to real world use cases. So I'm going to talk about the carbon agent. I'm going to show you how you can build this agent using open source tooling. And we're actually going to fabricate some data so you can replicate this entire process and even extrapolate it to your own use cases without having to worry about data access or cloud architecture, at least at the initial level. And And hopefully this will empower you to build your own agents as well. So what is an agent? An agent is essentially an intelligent bit of software that uses generative AI to understand, decide, and act. And it's really this last point that underpins what an agent is. It has the agency to decide how to go about doing a certain task usually without the intervention of a human. So why are they useful? I mentioned automation. So quite often for very repetitive tasks, we can build these agents in a robust way that they can do certain tasks end-to-end independently with little human interaction. Enhanced decision making. So obviously these agents can consume much more data than a human is able to effectively. So you get enhanced decision making because it's grounded in all of those data points. Scalability. The way agents are typically built, if you have an end-to-end process but want to add an additional step into that process, it's quite easy to add that in, just the way that they're organically built. And of course, 24/7 availability. So us as humans ideally need 8 hours of sleep per night. I've definitely not been getting that lately, but agents are 24/7 available. So that's definitely helpful from a productivity point of view. So some examples of how we can use agents every day. So personal assistants, and I'm going to go through this one in a little bit more depth in a moment. But if we need, our PAs probably are monitoring our email inboxes, prioritizing what tasks need to be done in what order, and then booking meetings, booking lunch, booking travel appointments, etc. So they have a whole host of capability. So we can build this into our agents. Research agents, this has been covered quite widely in industry. A lot of the big tech firms have got some great blogs on this as well. But if we have a hypothesis, a lot of students will be putting together their thesis. You start with a hypothesis of what you're trying to prove or disprove. You want to collate all that evidence, understand the arguments for and against, and then draw your conclusions. Likewise, with the sales agent, you can also build in a lot of hyper-personalization and really nurture those leads accordingly. So this is perfect for an organization like a tech consultancy, where you're probably servicing quite a wide range of domains, from finance to legal, healthcare, education, security, so forth. So when you're talking about your services, you want to really make sure it's tailored to their problem. Agents allow us to take on a multitude of different personas and act accordingly. Customer service agent. So this is probably the one that we've got probably the most amount of familiarity with. A lot of us will order things online, and we'll want to know when our order's arriving, if it's late, if there's something missing from it, or you received the incorrect item. If you've returned something and you want to know when you're getting a refund, these are types of activities that agents can help us with end to end. They have access to all those underlying databases that they can draw on in real time to be able to help us with our queries. And then developer agents. We've all seen a lot of the stats around how there aren't enough AI engineers and developers in general. So if we can augment our capability with developer agents, that gives us that scalability. So just want to go through some common architectures of how these agents are typically set up. So this is from the LangChain blog, but essentially highlights 3 common architectures. So the single agent is one that we're going to build today when we're building out our carbon agent. And ultimately, this agent has just a multitude of different tools that it can draw upon to answer user prompts effectively. We've got the swarm type architecture. So here we've got a few different sub-agents that are basically offloading and interchanging different tasks in between themselves according to how they see fit. And then you've got the supervisor agent, which is quite a common architecture, and another one that we'll explore in a little while, where you have essentially like a management agent that is dealing with the user prompt, offloading subtasks to different sub-agents, And then that information, once they've completed their task, is being passed back to your supervisor, which then interfaces with your user. So you might ask, what is the difference between just chaining loads of LLM calls versus an actual agent? So in chains, we've got an orchestrated pipeline. It's predictable, it's rules-based. There's not that much complexity within the workflow, so it can be hard-coded, and there's not really that need for lots of different. So if we think about it as a decision tree, there aren't lots of branches coming off the main kind of trunk of the tree. It's very repeatable. In comparison, the agents are autonomous decision makers. So they're using different tools in order to ensure that they are delivering against the goal that the user prompt has initiated. So just to apply this to an example a little bit further, if we think about an assembly line, if we take making shoes, for example, each part of the assembly line will have a very specific task, whether it's adding the shoelaces or gluing the sole, etc. It's one step done repetitively over and over again. It doesn't really change based on different circumstances. So we can just chain a whole bunch of LLM calls in that scenario. In another scenario, if we're thinking back to the personal assistant, we need some agency here. So if we have our supervisor agent monitoring our emails, defining and prioritizing what tasks need to be done, offloading to those sub-agents, and then relaying back. So if it's summarizing and drafting emails, it will need to know, well, I need to understand the initial email. What is the ask? Who am I replying to? What kind of template should I have, etc. Booking meeting rooms and booking meetings. If you're at an enterprise level, you're probably likely to have a multitude of different offices in different geographical jurisdictions with different platforms behind it. So they'll need to be able to use those and book meetings accordingly. Likewise, with booking travel, it's not just one platform, depending on where we're traveling to. So if I'm traveling from the UK to India, I'm definitely not going to be traveling by taxi. So it would need to have that intelligence to say, I need to book a flight here. I'm servicing this particular client. So if they're traveling with me or a part of the journey, I need to make sure that I've put in those requirements as well. So there's a lot more complexity, even though it is generally quite repeatable. There's a lot of nuance and understanding of the scenario that needs to happen in order to make the right choice. So when do we use agents versus when do we not? So I've kind of covered a little bit around if we have repeatable rules-based tasks that have a lot of complexity and nuance in. So we're managing multi-step processes across platforms, then agents are perfectly suited. Likewise, if we need to perform high volume information retrieval and summarization, that scale is also great, and we can use agents there. Where we would not use agents, more importantly, is any scenario where there's high risk or irreversible decisions. So if we think about in a business scenario, if the financial implications are extremely high, that's probably where we wouldn't use agents, or we'd look to build in a lot more controllability with human in the loop, etc. Likewise, if it's going to impact human life in the health setting, we'd definitely not want to use agents independently, at least within that scenario. If we've got poor quality or biased data, that's also not a great use case for agents or any machine learning in that scenario. Because what will happen is we're building a lot of the responses based off understanding of poor data that doesn't accurately represent what we're trying to convey. So those errors will compound downstream. So that's not ideal. We want to make sure we've got those foundations right. Likewise, anything where we don't understand exactly how a human is doing this, we wouldn't use agents. So a standard operating procedure is essentially a step-by-step description of how a human would do that, and that needs to be translated into our prompt. So if we can't give that information and instruct the model adequately, those errors will again compound. So I'm going to show you guys later on how to build a carbon agent, and I'm going to be using LangGraph. So the whole LangChain kind of ecosystem is open source, it's very developer friendly, but they've not just catered to developers, they've also catered to business users and analysts, people that don't necessarily have extensive coding skill with Langflow. So I've put a link there at the end of the session that points you towards Langflow. So this is a kind of drag drop interface that allows you to prototype very rapidly. But I will focus on LangGraph. So the thing is with agents, as we give them more and more autonomy, their reliability and performance generally decreases, which is what we see here. But the way that LangGraph, the kind of tools that LangGraph have built in their SDK is really great in terms of persistent streaming, human in the loop, and controllability. And all of this allows us to get more reliability from our agents. So why would I want to build a carbon impact agent? So if we think about foundational models like GPT, Llama, Mistral, Gemini, etc., it's very well documented how energy intensive these models are. So typical foundational models use around 1.7 billion gallons of water. I googled this a little bit earlier. That's probably equivalent around to about 20 million bathtubs, just to put that in perspective. In terms of just training GPT alone, that took around GPT-3 specifically, it took around 550 tons of carbon. That's around 300 return flights from New York to San Francisco. And on average, data centers are consuming around 560 billion litres of water annually. And this is projected to double. So we're really reshaping our global electricity demand. I think I read in another article that since GPT, a lot of data centers are putting towards 1 to 2% of their energy usage just for GPT interactions, essentially. So this is, we know that this is a problem that is going to continue to increase, but it's also driven a lot of good and a lot of focus on how we can remediate. So we're already developing great foundational models in terms of biodiversity and predicting climate disasters. We're using these models to optimize our grids, and we're even coming up with better technology. So model compression, neuromorphic chips, better materials that are less energy intensive. So that's very well documented. What isn't so well documented is the downstream AI applications and their consumption. So a lot of organizations will use OpenAI models within their applications, probably hosted on Azure, etc., in a very secure environment. But that consumption within the organization also has downstream emissions associated with it. So this isn't really actively built in to development from what I see. Obviously, there's been a big hype around we need to get AI embedded within our organization. We don't want to be left behind from that competitive standpoint. But with that, there's been no green AI strategy. I think before the generative AI hype, there was a lot of focus on sustainability and how that featured in organizational strategy. And what I am seeing, though, is that energy reductions in AI consumption are typically the byproduct of choosing a smaller model to minimize cost, or as long as performance is not also jeopardized. So that tends to be a kind of byproduct as opposed to a conscious decision. And the most important one, we're not actually measuring at all, from what I see in large parts, what the consumption of those AI applications in terms of carbon footprint actually is. And that one alone, if we were doing that one, we could already, off the back of that, develop various different strategic tactics to minimize our impact. So we could develop more sustainable prompts. We could schedule workloads so that they're used when it's the optimal time within grids. And we could also start caching responses. If we know users are repeatedly asking this particular type of prompt, we could cache that so that it's not calling the LLM every single time. It's already surfaced there for them. Okay, so getting the foundations right. Before we do any kind of agent development, we want to ensure that we've got the foundations right. And this doesn't really matter whether you're doing something as like a prototype or you're designing an entire production enterprise solution. This will underpin performance from the get-go. So we want to make sure the data quality is great. And that's not just in terms of distribution, missing data, is it biased, etc. But we also want to ensure that the way that we're extracting particularly unstructured data is correct. We're chunking in a way that's relevant for our use case, and we're vectorizing effectively, with also extracting out custom entities that might also be beneficial and augment the capability of large language models. We want to ensure that we've got that step-by-step breakdown in our operating procedure, because we want to then inform our prompt to be able to act in a certain way according to that step-by-step process. And then finally, with prompt engineering, the 5 kind of key pillars are: we want to instruct the model to take on a particular persona, and I'll go through an example of this working well in a moment. We want it to ask more questions, give it templates of how it should respond, ask it to reflect so that we get more reasoning capability, and provide contextual understanding through a few shot examples, so examples of exactly how it should act in different scenarios. So just looking at the standing operating procedure and prompt translation in a little bit more depth, if we go through to our assistant that is summarizing documents, they're likely to read the document, identify the purpose and intent of the document, extract the key points, highlight any supporting evidence, and then probably end with the 1-sentence conclusion. And if we're translating this into our system prompt, we want to say, you're an assistant that is specialized in document summarization. So the intent is very clearly communicated. You are to follow the process when summarizing documents, do not skip any tasks, and complete them in order. So we've given that translation of how the human would do it into the prompt, and we might even add in a few short examples as well. So writing a good prompt, there are many different ways of increasing the performance of AI solutions, and prompt engineering is probably the one that's the cheapest and also quite effective in most cases. And as I mentioned, there are those 5 pillars that we want to kind of keep ensure that our prompts are adhering to. So instructing the model to take on a particular persona, suggest better questions to guide the model, provide expected templates of output, improve reasoning and asking it to reflect, and then obviously adding context for accuracy. So in terms of the example, so this is actually taken from the Microsoft documentation. If you guys are interested in AI engineering, the AI 102 content is where you want to look for this particular type of example, and it takes you through agent building, and not in quite the same way, but it does show you many capabilities, including how to use MCP servers as well. But here specifically, we're giving, this is the distinction between not giving the model any kind of instruction, so essentially using like GPT out of the box essentially, and this is where we've given the model a system prompt. So the system prompt is: you are a seasoned marketing professional that writes advertising copy for an audience of technical customers. So the model in this scenario understands that this is the persona it's trying to replicate. So when it receives the user prompt, write me a 1-sentence description of a CRM product, the response quality is quite different. So you can see here, this is just based on its inherent knowledge. So it's saying a CRM product is a software tool designed to manage a company's interactions with current and potential customers. In comparison, where it's taken on the persona of the marketing professional, we see experience seamless customer relationship management with our CRM product designed to streamline your business operations, enhance customer interactions, and drive sales growth with its intuitive interface and robust analytical tools. So one is very much fit for purpose of advertising copy, the other one isn't. So those system prompts are really key to get right. So finally, low code versus code first. Both have benefits and disadvantages. Low code is great in terms of rapid prototyping. You can get some results very quickly. You don't really require any coding experience or a lot of technical expertise. And the cost is generally quite low up front. So if you're using something like Langflow, it's quite effective as well. With a code first solution, and particularly within enterprise organizations, you want additional customization. They'll probably have a whole bunch of disparate systems that we need to integrate with, would need to build in more functionality over the top as a result. They'll need additional governance pipelines. It needs to be scalable and allow for innovation. So if we need to swap out models because a new model is available that's a little bit more performant, that needs to be quite robust in the way that we build them. So when it's built from a code first perspective, that's obviously a lot more agile to that. So there are just two scenarios to bear in mind as to when to use one or the other. I think low code are brilliant for prototyping and definitely get the ball rolling very quickly. So onto the carbon impact agent. So I mentioned we've created our personal assistant. So we've got our supervisor agent and our sub agents, one that's summarizing and drafting emails, another one that's booking meetings, another one that's booking travel. So we're going to imagine that this is deployed in a large legal enterprise, and I want to collect all of the telemetry from this application in order to understand what are the emissions associated with each of its activities and how could I potentially start reducing my impact. So what the telemetry data that I fabricated basically defines task, tokens, the time it took, the CO2 impact and cost. So when a user comes to this assistant and says, how much emissions are associated with drafting emails, it's able to call upon the right tool, of which there's three here. We've got a carbon calculator, a cost estimator, and a carbon optimizer, and surface back an adequate response. Likewise, if we're looking to continue on the conversation and ask how might I improve this, it would use the relevant tool to be able to answer that. So this is a very simple design at the moment, and out of our checklist of AI development, it's only really dealing with the first one. We've got a very clear objective. We've not really said how might we improve this with understanding how humans do this or improving the prompt in any kind of way. We haven't added any complex data, so I'm not doing any indexing, vectorizing here. We haven't got a human in the loop. We're not looking at evaluation or any reinforcement, and we're not doing testing and monitoring at the moment. But from the ground level, you just want to build something simple, and then we can iteratively build more complexity. And so there are a whole bunch of open source packages that do a lot of carbon calculating that we might want to leverage at a later date instead of using the very basic carbon calculator that's in here at the moment. But I'm going to show you how I've built this using LangGraph. So I've put it in a Jupyter notebook and then refactored it into a more kind of software engineering approach, just so that you can clearly see the output. So this is the fabricated data that we have. So here we've got event, timestamp, what department it was, HR, legal, IT, ops, etc. What type of task was our PA agent doing? Booking lunch, arranging a meeting, drafting a response, etc. How many tokens did that take? What was the duration? What region was that compute power used in? The energy and CO2 impact associated, along with the cost. So then we've gone through, I'm using a GPT-4o mini model here on Azure, but you can quite easily use a local Llama model and run everything locally. We've gone on to then define our tools. So we've got a few different tools here. We're retrieving our data, our telemetry data of what the PA agent has done. we are calculating the carbon emissions associated. Again, if we've got different models running for different tasks and we build the complexity up in the PA agent, this will also need refining as well. We've got the cost estimator tool and the optimization tool. So we've bound all of these to our LLM model, and we've given it a very simple system message. So you are a helpful assistant tasked with analyzing telemetry data and providing a carbon footprint, cost, and optimization recommendation for a legal PA agent. So then we're actually using the LangGraph package here to actually build out that agent. Very simple at the moment. And this is the mermaid graph of like what it functionally looks like. So you can see here I've tested it locally, but if you're particularly within an organization, you show this type of thing to a lot of business users, it doesn't really resonate and it doesn't give them that user journey. So I think UI and AI are very tightly coupled these days. So which is why I refactored this code to basically, to basically use create a chainlet application essentially. So we have our carbon agent here, which is literally what you saw in the Jupyter notebook. And then I've basically created a very simple chainlet app here. I will make all this available on GitHub. So if you did want to use this, you can do. But it's quite simple. And if I take you through to the UI, it looks a little bit like this. Let me start a new message. We'll start a new chat session. So, oh, not that. Let's go back and copy our, what is the carbon footprint of a draft response? And this is just a nice thing to show to potential stakeholders or users in terms of how it might work. So it's returned that we might ask, how could I reduce the emissions associated with draft responses? It's taken a few minutes to think about its response. There we go. So this is where we might start refining the prompt essentially, because it's basically given a very comprehensive overview, but it depends who is actually reviewing this and what changes they're going to make. If it's somebody like a developer that's looking to change how the PA agent works so it's a little bit more sustainable, then fair enough. You might start talking about prompting and token usage, etc. But if it is a product owner or a business stakeholder, they probably don't want to know, they need this language represented in a slightly different way in order for them to take action off the back of it. So this is where we might start thinking about different personas and the types of sub-prompts that we might have according to how we want that information to be surfaced back to the user. So if I go back to our recap, so we've covered quite a bit around what are agents, when to use agents, how to design effective agents, and I've shown you how to build a very simple agent that could look at carbon impact using LangGraph. As I mentioned, we could start, there's many different ways that we could start building complexity into this and obviously improve the performance. So prompt iteration is one thing, adding more complex data, but even using some of those open source carbon calculators. We might even want to put human in the loop if it gets particularly complicated in some areas or it's got high risk associated. We definitely want to start building an evaluation, like, is it actually performing? Do we want to cross-check that the emissions that it says for a particular task is actually that, and just validate that. And then obviously feature complexity. So I've left a few resources. Like I said, I'll put this all on GitHub. The LangGraph course is a great one. I really also like this Azure architecture blog that Microsoft have written around how developers can actually, some of the tactics they can use to build sustainably from the ground up rather than as an afterthought. So that's a really great one to look into. There's the open source carbon calculators there. And if you are interested in the low code stuff, then I've linked Langflow there as well. But that's everything from me. Thank you so much for attending the session.
Yeah, that was great. Okay, I believe you will share this slide with me as well, right? So that
Yes.
folks can get this. Okay, so we'll just add it to the comment section later on. So one question did pop up it is at the earlier. So the question was, can powerful AI agents be built without advanced machine learning knowledge? So yeah.
Yes. So what I've kind of seen over the last few years, so before, when I was at the early start of my career, we were building machine learning models using regression, random forest, neural nets, LSTM models, etc. And you do need to have understanding of how to tune parameters and the intricate statistics that are associated with machine learning. Now that a lot of these agents are consuming models that have already been developed and are consuming them rather than using them, you don't need the ingrained statistical knowledge on the same level. But what you do need is to understand enough around how data is surfaced to the model and how that impacts performance. Because ultimately, if you're not getting the results that you anticipated at the end, you need to understand, well, how and why. So you want to kind of backtrack, and evaluation metrics will tell you something. Traditional, like there are a lot of NLP type metrics that we can use off the back. But there are also, you want to also think about building your own custom evaluation metrics. So from what I've seen in the consultancy sphere, the human benchmark or judgment of specifically in this arena where we're talking about very verbose messages that are returned, is still probably highly weighted in comparison to the traditional NLP metrics that you get off the back, because ultimately it's the users that are judging the performance as to whether it's adequate or not. And we want to start building those custom metrics in the evaluation process. And if they're not performing, then we want to go back and say, well, okay, let's start from grassroots. Is it at the foundational layer? Is it because the data hasn't been extracted in the right way? So the model's getting confused as to drawing the right citation back, or there's a lot of nuance, particularly in the legal sphere. So there's a lot of terms, and even in medicine, actually, there are a lot of terms that are specific to that field that you don't find in every day. And these models have been trained on a lot of generic material. So you really need to then either start building that complexity and that knowledge within the prompt, or you need to start thinking about fine tuning. So there are different ways, but I think you really need to understand data. I think that machine learning and statistical metrics are useful, but you've got to really think about it as this is a problem that you're trying to solve, and then you can apply that kind of very analytical interrogation to the data and to the process to understand how to improve it.
Yeah, so that's one of the reasons. Like you were talking about agents, right? So we were talking about, first of all, agents, at the same time carbon emission, right? That's our goal, and how we can reduce that. So like the whole series, the goal is like, if you are learning about AI agents, you should actually have obviously the basic machine learning, right? So that you can't backtrack. You have to backtrack some time eventually when you're working in a production level one. So yeah, obviously many people are like, I do see in real life as well, like folks don't have that much of knowledge about machine learning, but they want to go for the agents building, and then they get stuck. That's one of the things, because then they can't know, like don't understand like what's the issue basically. Sometimes even GPT or others, the issue or error they do give, folks don't understand, right? So obviously, I believe
I
you have
understand. So one resource that I would probably highlight that will help with that, and I point a lot of people to this because I think, like, obviously I've had the benefit of being around when we were using machine learning and seeing it through the generative AI hype cycle. But if you're trying to, like, specifically for students that are trying to, like, well, what do I learn first and how? So Microsoft have put together an AI fundamentals course, and in there it covers the basics of machine learning, like probably enough that you need to get familiar, and then it goes on to generative AI development. So I think
Mhm.
you can quite easily, in a very short period of time, get the kind of comprehensive knowledge that you need.
Mhm. Okay, that would be great. So I believe you'll share that with me, and I also
Absolutely.
know the resource. Obviously, I believe it's in on GitHub as well. So
Yes.
yeah, we can just add that into the comment section as well. Okay, so
Okay.
my question should be, so obviously carbon emission is a big problem for sure, but so what are you seeing in the like the current trend for the companies? What are you seeing that, especially in Europe or US? Are they actually focused on this thing right currently? Like they want to reduce that
Yeah.
or?
No, so I think this is unfortunate. So I actually, one of the products that I used to work on a few years ago was focused on sustainability, which is why this is a particular interest of mine still. Because the climate challenge that we have has not gone away, and that these models, whilst they've got a lot of positive benefit, they are energy intensive.
Mhm.
So we really need to think about, well, how can we quickly build in better capabilities to use them more effectively. There are organizations that they don't want to be left behind and they want to try everything that's available, and I get that. But at the same time, how are you using them, and then how are you like shelving them when you're not using them? So I think in terms of what I see across the landscape, particularly in Europe, obviously there's a lot of ESG reporting and compliance that needs to
Mhm.
be generated. And it's one thing to look at your supply chain, and it's another thing to look at like the very thin stack that is your technology stack, which is obviously quite rapidly evolving. And I think there is definitely that education gap, but I think if there are more off the shelf tools that empower people to measure carbon impact, and rapidly remediate, specifically low hanging fruit, right? Things like if you know your users are asking the same question every single day, then cache the response and just surface it to them. It doesn't need to be asked by however many users every single day.
Mhm. Yeah, but obviously, at the same time, like but the whole system should be like the pipeline should be built in such a way like it should be optimized, and that's how we uh, can make sure that there are less carbon emissions, right? So that's kind of, I believe it will take time because currently it's the AI race, right?
Yeah,
So there are lots of
exactly.
things that's happening. Once things do cool down, then maybe that can take the this process and go for this one carbon. Okay, but obviously we have to go, we engineers as a whole, we have to solve the problems, we have to deal with it. So okay, I don't see any questions yet, so yeah, let's wrap up the session then. And
Absolutely. Thank you
thank you
so
so
much,
much.
Sharia. Thank
Yeah,
you
thank
so
you so
much for
much,
hosting
Rashna.
me.
Yeah,
Thanks,
that was
everyone.
really an awesome session. So obviously you'll share the link and the slide link with me, so I will just add that into the comment section and folks can add their questions. I will pass it to Darshna later on if there are any questions. Okay, thank you so much,
Perfect.
Darshna, for your
Thank you
time
so
then.
much.
Okay, see you.
Take care. Bye bye.
Okay, so that was it. We learned a lot about agents and the real world problem, specifically the carbon emission problem. So in developer world, if you're working with it, if you're building some product, you will find that this problem is something we do have to deal in real life, obviously. Specifically, when we are generating something using machines, this carbon emission is happening. So that's one of the things we have just today talked about, and talked about how we can use agents and easily know like how much carbon emission this thing is showing and so on, a lot of things. So okay, thanks so much. If you have any questions, feel free to add in the comment section, and see you in the next stream in the next week. Thank you so much.